That's what I'm talking about right there.
That doesn't make you want to throw up. I don't know.
What are you talking about? That's
The entire presentation is that color. That's right. Take it all in. Take it all in.
Easter? Today's the 18th.
Just the 17th. But I thought we were going to do this yesterday. So I was prepared for it yesterday.
You thought we were going to do this your
That sounds good, doesn't it?
And then yesterday when we did do it, said we're going to do the relay next week. Sorry.
Did I say that?
Yes.
Yeah.
Does that. We're going to do it today, get it out of the way. All right, so this is the relay response for the filter wash station, blow valves closed. Obviously, we're the lilac team. Go lilac. All right, the background. Going to show the inputs, the outputs, the steady state operating curve, the actual filter wash system. We're going to go over the theory and parameters of the system. And then we're going to show the results and conclusion. All right, this is the block diagram. We have a motor input goes into the system, which puts water out of the system in pounds per minute. This is our steady state operating curve. I chose 20 to 100% because basically it was the only operating range that would give me any usable data that was decent. This is the actual filter wash system. We have the controller that sends the system, or the input here, which sends it to the motor, which pumps the water, the transmitter that sends to the controller on the control panel, telling which, does it need more or less water. And since we don't have the filter wash, or the valves are closed, these basically aren't there. And the only one that comes out is this filter washing nozzle here. Alright, for the theory, for the student T's part, I used 3 different cycles of the same system, or the same test run. And this is the formula I used for the uncertainty off of Dr. Henry's website. For the parameters, the floor was set at 20%. The ceiling was set at 100%. The set point value I got from the previous experiments at 18 pounds per minute. For the relay, we had to set the controller gain to some high number. I basically just put 9s in until it wouldn't let me put any more in. And then the length of experiment was 15 seconds because that gave me the best looking graph.
Oh, man.
Basically, this part is just showing what is what. This line here is the relay response. This is the set point value, and this is the actual output of the system. The calculations to find the ultimate frequency is just 1 over the period, T being the period. The amplitude ratio is just the controlled variable over the manipulated variable. Then these are the controlled manipulated variables. And then the ultimate gain for the relay is the 4 times the manipulated variable divided by pi times the controlled variable. Right. This is the same graph, but this actually has the what the manipulated variable, the control variable, the actual period, and the T. I only showed on here 1 cycle. The actual period for the average here is 3 seconds. The actual, can't see that. Should probably look at this a little more. The time shift here is 1.3 seconds. And then our from the ceiling to the floor is 80%. And then the amplitude of the control variable here is 9.6 pounds per minute. Alright, this is the result of the 3 different cycles that we went over. This part here is 1, this is 2, this is 3. The cycles are pretty close to each other for the period, the frequency, obviously the manipulated variable is the same, but the amplitude ratio and the gain and the time shift were pretty similar. I'll show the uncertainties on the next. The period was 3 seconds plus or minus 1 second. The frequency is 0.3 cycles per second plus or minus 1 cycle per second. The amplitude ratio was 0.12 pounds per minute per percent, plus or minus 1 second, or plus or minus 0.01 pounds per minute per percent. The time shift was 1.3 seconds, plus or minus 0.3 seconds. And the ultimate gain was 10.6 pounds per minute per percent, plus or minus 1.1 pounds per minute per percent. That's it. You guys like the color, right? Sexy? Yeah?